Hello everybody and welcome to part 2 of the notes for assignment 1 in ABS. Alright, in this lesson I will be going over the order of operations, as you can see right here. PEMDAS, otherwise known as GEMDAS. So I'm going to come right down here to the bottom and write GEMDAS. So what does this stand for? P is generally meant to stand as parentheses. G sometimes gets used for grouping symbols because more generally parentheses are representing a set of grouping symbols. And the reason that I'm going to stick with G here is that this right here, up here in number 26, these absolute value bars are considered a set of grouping symbols. In addition to that, things like this here over number 27, the top of a fraction or the bottom of a fraction is technically a grouping symbol. We have to figure out, when we simplify this in a few minutes, we have to figure out the top. We have to simplify that to a single number. We have to simplify the bottom to a single number. Then we can do the division between them. So we have the grouping symbols that we will take care of first. We have exponents that we will take care of next. E is for exponents. MD is multiply, divide, and we just do those if we need to. We don't do one before the other. In fact, you'll see up here in example 25 what happens if you only have multiplying and dividing in an expression. And similar, we have addition and subtraction. One of those operations is not more important than the other. So if you see a bunch of numbers being added and subtracted, you're supposed to do it from left to right. Let's get into the examples. So example 24 here, we have 2 plus 5 multiplied to 6. And if you look down here at the GEMDAS, multiplication and division need to happen before we do any addition and subtraction. So we will multiply 5 to 6 and get 30. They're both positive. Now, what students like to do is they like to just not worry about this plus sign. But we haven't added anything yet. All we did was multiply these two numbers together. So we have to add 2 to the 2 to the 30 and get 32. Next, in example 25 here, we have two operations. We have a division and we have a multiplication. What needs to happen here is you need to perform these operations from left to right. So we're going to start with 40, divide it by 2. So I'm going to do this first and get 20. The multiply by 4, we haven't done anything. We have done no multiplying yet. We haven't used the 4 yet, so we have to bring all of that along. Then we can multiply the 20 times the 4 and get 80. As I already mentioned for example 26, these absolute value bars represent grouping symbols, so we need to take care of that first. So why don't we take care of that? The absolute value of -1, it's the distance from 0, it's 1 away from 0, or you think of it, absolute values turn any number into a positive number. So that will just turn into 1, and everything else stays the same. There it is. Now, we don't see any exponents, so we don't have to worry about exponents. We took care of the grouping symbols, exponents. Then we have to worry about multiplication and division down here. And with the multiplication and division, we just have to do it left to right. So what numbers are being multiplied and divided? Well, we have 18 divided by 3 multiplied to 4. So 18 divided by 3 would be 6. That's 6. 6 times 4 in that case would then give us 24. We still have the plus 1 that's part of this. We haven't done any adding or subtracting yet. And technically here, since we don't have any more grouping symbols, we would have to add 6 to 24 and get 30, and then add 30 to 1 to get 31. Next example, example 27. We have the top that needs to be simplified. Again, I said if you have multiple terms or a big expression in the top, we need to simplify it down to a single number before we can simplify the entire fraction. So we do have a set of grouping symbols right here. We've got 9 minus 6. That will turn into a 3. So we have 7 times 3 plus 3. We have to perform the multiplication first. So 7 times 3 is 21, plus 3 is 24. So the top of this fraction simplifies to 24. In the bottom, you can see we have our first exponent here. This is 3 to the second power. So we have to take care of the exponent first. Exponent 3 squared gives you 9. The minus 3 comes along, which simplifies to 6. 9 minus 3 is 6. So we have 24 in the top and 6 in the bottom. As you can see right here, 24 divided by 6, that's what we got. 24 here, 6 here. And if you divide these out, you will end up with the answer of 4. Next example, number 28. So with number 28 here, we have 5 to the third power minus a set of grouping symbols and all this stuff going on. Oh my goodness. We have to simplify everything in this set of grouping symbols very similarly to how we simplified everything in the top and the bottom separately for this fraction. So we're inside the grouping symbols. Do we have any other sets of grouping symbols inside of this? No. So we can just jump right down to exponents. So we have an exponent, 9 to the second power. We have to multiply the base this many times. So we would have to multiply 9 times 9 and get an 81. So we can do the 81 here for the 9 to the second power. And I'm just going to sort of seamlessly flow over into, since we're done with exponents, we can go into multiplying and dividing. 4 times 11 is 44, and it'll be positive because both of our factors here are positive. Now, what sign goes in the middle here? Well, if you remember back to example 23 from the last video, that was the very last example, we had a number that was being raised to the second power with a negative in front of it. The negative will follow. So here, negative 5 cubed. We haven't done anything with that yet. So still inside the grouping symbols, we're done with the exponents, we're done with the multiplying and dividing. We need to go to the addition and subtraction, which means we just take 44 minus 81. Since they have opposite signs, it's a positive 44 and a minus 81, we have to subtract them, but then make sure that the result gets the sign of the larger number, which would be negative 37. From there, 5 to the third power becomes 125. It says we have to the exponent says we have to multiply this many bases together. So we have to multiply 3 5s together to get 125. From there, with the subtraction from the last video, you can remember that subtraction just means add the opposite number. So I'm going to have to scoot this over a little bit. It's 125 plus a positive 37. So we can add these numbers together pretty simply and get 162. Okay, from here, what I want you to do is pause the video and try these three for yourself. So here you can see are the solutions for these last three examples on this slide. So for number 29, we have to follow the order of operations. So we need to look inside the grouping symbols first, add 1 to 2 and get 3, The parentheses are still there, right? We haven't done anything with the grouping symbols yet. We have only added the 1 and 2 together to get 3. The parentheses are still there, just like they were back here. Right? I hadn't done anything except for square the 9 and multiply 4 times 11. And even then, when I combined these two numbers to get negative 37, the parentheses were still there. Anyway, so back to the question. We added 1 and 2 to get 3. Then you notice we have only multiplication and division going across, so we have to work left to right. So 6 divided by 2 is 3. The parentheses with a 3 in it come along for the ride. 3 times 3 is 9. This is a lot like number 27. We have to simplify the top. There's a set of grouping symbols here. 8 minus 2 is 6, still in the grouping symbols. Bring the 4 along in front of that set of grouping symbols. In the denominator, the bottom, we have 3 plus 9 is 12. So the bottom is simplified all the way. In the top, 4 times 6, we can multiply that to get 24. 24 divided by 12 is 2. Lastly here, number 31, this goes back to squaring or raising different bases to a power. And we have a base of negative 3, and we need to multiply 2 of those together, so a negative 3 times a negative 3 is a positive 9. Something similar over here, we have a negative 4 that we need to multiply 2 of them together, so a negative 4 times negative 4 is positive 16. We can take care of all of the multiplications then. 5 times 9 is 45, 2 times 16 is 32. The minus sign, we haven't done any addition or subtraction yet, so it's still in between the 45 and the 32. 45 minus 32 is then 13. On this slide, you can see I start with some examples fully worked out for you. That's because they are very similar to previous examples. Go through step by step, see if you can convince yourself that I have the correct answers here. Now these other three I have not done because they present something new. So I want to start with example 35. This is going to be the easiest one for me to work with right now. But we're still working with the order of operations. So we can work inside the grouping symbols first. So we'll do 3 times 5 to get 15. That's still going to be raised to the second power, minus 3 times 5 to the second power. The second thing we need to take care of, again, are the exponents. And yes, we have exponents, so we should definitely do that. This is telling us that we should multiply 2 of our bases together. And our base here is a positive 15. So 15 times 15 is 225. We have a minus 3 still, and we have a multiply by. Let's see. This is telling us we need to multiply 2 of our bases together. So 5 times 5 is 25. Then we need to do any multiplication or division. We only have one. It's right here. 3 times 25 is, in fact, 75. And I need to be putting equal signs here. It's still subtraction, 225. 225 minus 75 is 150 for a final answer. Up here for number 33, you can see what happens here is that we have 2 different sets of grouping symbols. In fact, we have a set of grouping symbols inside another set of grouping symbols. So we have these blue parentheses inside of the red brackets. From there, we have to work in the innermost set of grouping symbols. So we need to simplify this down first into a single number. Then we have to simplify what's in here, the red brackets, into a single number. So let's get cracking here. Negative 1 plus 6. So we can subtract those two numbers. 6 minus 1 is 5. And that result will have the same sign as the largest number. So it's going to be 5. And we're still in the parentheses here. Everything else is -3 plus 2 in the red brackets with a -2 being multiplied in front. So now we just have to simplify the inside of this set of red brackets. We have a multiplication here. That is 10. 2 times 5 is 10. -3 plus 10 would be 10 minus 3 is 7. So inside the red brackets now, we have a 7. And we still have a -2 being multiplied out front, again with my equal signs. So then we have a -2 times a +7. Those factors have different signs, +7, -2. So our answer will be -2 times 7 is 14. Now I want you to pause the video again and try this one for yourself. It's a little different because it's kind of like this one here that we just did, number 33, but it has an exponent. Go ahead, pause it, try it. I'll be back in 5 seconds. Here's the solution. We have to work in the innermost set of grouping symbols here. So I'm just concentrating on the 2 minus 3 to the third power. So what this exponent is telling us is we have to multiply 3 of our bases together. So 3 bases. 3 times 3 times 3 is 27. 2 minus 27 becomes -25. 4 times -25 is a -100. And you might be wondering why I put parentheses here. You never have a negative number following an operation without parentheses around that number. Then we can add the opposite. So this would be like adding 100. 11 plus 100 is 111. And this whole time the divide by 37 has just been there until we can use it, which is the very final step. 111 divided by 37 is 3. The final topic here for this video will be the distributive property. And the distributive property, I need to define a few things before I can fully explain what the distributive property is. So let me get this on the screen. So a little bit of vocabulary here. Terms are mathematical items that are either added or subtracted, and factors are mathematical items that are multiplied or divided. So what distributive property tells us is that we can have two factors like this. I've got a factor A and a factor B plus C. And one of those factors will have two terms, right? Either added or subtracted. And in order to multiply these two factors together, this A times this set of grouping symbols, what we will do is we will share, or we will distribute, the single factor to each term in the second factor. So you can see we have B plus C. You can still see it kind of like, forget the A's are here, you see it's B plus C, but each of them, the B and the C, got multiplied by A. And it doesn't matter if you have addition in the grouping symbols or subtraction in the grouping symbols. Distribution works just the same. So for example, we have in this number 38 here, we have our first variables, awesome. We have 4 times x minus 3. All we have to do is we have to multiply the 4 times the x and the 4 times the -3. 4 times -3, 4 times 3 is 12, and there's a subtraction happening in between them. So 4 times x and 4 times 3. That's usually how we denote this. We draw a couple arrows here. We draw as many arrows as there are terms in the grouping symbols. And in this example, there are 2 terms. But then we can also have like terms. So forget about like variable terms. We'll talk about that in a couple minutes here. But like terms. Like terms are terms that can be combined. And in order for terms to be combined, they have to have the same variables, and those variables within each term have to have the same exponents. And we'll get more into that as the class progresses. But right now we're going to keep it relatively simple. So for example, when you take a look at example 39 here, what we have to do is we have to figure out where is the multiplication happening. Well, the multiplication is happening right here, right between the 4 and that set of parentheses. So just like we did for example 38, we will have 4x minus 12, but this 2 plus is in front of everything. So now we have terms that can be combined, and the terms that can be combined are what we call constants. So that's this one here, constants. And constant terms have no variables. So what are the terms here? The terms are positive 2, positive 4x, and a negative 12. So the term includes the sign, either plus or minus, positive or negative, some number. In some cases we call it a constant, like these. In some cases we call it a coefficient. So it includes a sign. It could include a number, and it could include a variable. Those are the 3 things that make up a term. So what we can do, now that we know what a term is, we can combine terms that are only numbers. So like this 2 and this minus 12, we know we can combine those together because they're just numbers. You know how to work with numbers. You like working with numbers. So we have this 2 minus 12, which combine to give a negative 10. So we took this 2 and this minus 12 to get a negative 10. The 4x is still a part of our answer here. So we have this as our final answer for number 39. So the rest of these examples are just that, practice distributing. So I'm going to do 40A, 40B, and I will let you guys try the rest of them while we're here. So let's see, with 40A, you notice we don't really need to even use the distributive property here, do we? We can just go through and simplify 10 minus 8, and then multiply it by 3, and then add 4, and we're done. So 10 minus 8 is 2. That's what's in the parentheses. There we go. We can perform the multiplication. 3 times 2 is 6. And then I'm going to immediately add it to 4 because I'm out of space. So the answer here would be 10. How does that change when we start throwing in variables? Well, we can't simplify what's inside this set of parentheses. We can't simplify. It's as simplified as we can get. Remember, in order to combine terms, they have to have the same variables in each term, and those terms, those variables, have to have the same exponents. So that is not happening here, so we cannot combine that. But we can still simplify. We can multiply 3 times 10x and 3 times negative 8. And in this case, I made a big deal about keeping the grouping symbols because we haven't used them yet. We are using the parentheses to mean multiplication, so we don't have to use these grouping symbols, these parenthesis grouping symbols anymore. This is just 30x minus 8. And that plus 4 is still there. So now, just like we did with example 39, we can combine constant terms because this is just a number, this is just a number. 4 minus 8 is negative 4. I'm forgetting all of my equal signs still. This is 30x minus 4. Pause the video, try those other ones. I'll be back in 5 seconds. Here are the answers for these other 4 examples. This video is way too long. I promise I will break these up a little bit more in the future. Good luck. Go work on assignment 1.